Okay, guys, we're doing lesson day 5. This is not going to be your favorite lesson ever. You have to plan on pausing this video 1,000 times whenever you need to. All right, on the front of a worksheet that you have in your packet, you have projectile motion. Oh, by the way, you're also going to want a calculator in degrees. So you have projectile motion, and you're given these two equations here and here. You memorize both of these. Okay, here's the velocity, the initial velocity of something. Projectile motion is like when you have a golf ball that you're hitting and it's going over, or a tennis ball you're hitting and it's going over, or a softball you're hitting and it's going this way. Fireworks, anything that's going in that general direction, okay? We're going to have a human cannonball before the end of the day. All right, so this is the initial velocity. This is the angle at which you're going, and here is going to be your time. All right, over here when you have this y value, so here's the initial velocity, the angle, and the time like usual. This h is the height of your initial amount here. So like if you were golfing, you'd be hitting that off of the ground, so your height would be 0. If you were hitting like a baseball, it's probably 3 feet up in the air, so this h right here would be 3. You'll be given that information. Okay, right here, this gravity. If you take physics, probably you normally use 9.8 meters per second, but I don't really get meters, and so we're going to do feet per second. And so you can see that it's actually 32 feet per second. So if you do -1/2 times 32, I'm just going to tell you right now that you can memorize this as -16 t squared. So that's -1/2 times the 32. So you can just memorize this. Okay, these are, you know, in bubbles or whatever, clouds. Make sure that you remember both of these equations. Some of your homework problems might be in meters per second, in which case make sure that you use the -1/2 times 9.8. Okay, that's all there is to teach, and now it's just a bunch of problems. So Blake hit a golf ball with an initial velocity of 150 feet per second. So here's Blake, and he hits this golf ball, and it's going 150 feet per second in this direction, right? And he's at a 30-degree angle with the horizontal. So part A, to find the parametric equations, you're just using these two equations up here. X equals 150 cosine 30 times t. Easy. Y equals -16 t squared plus 150 sine 30 times t plus h. Okay, so we're assuming that Blake is hitting this golf ball off the ground. If he is hitting it from up in the air, that is some serious talent. But I don't think he's doing that. All right, so that is part A with the parametric equations. And then part B says, how long is the ball in the air? So the first thing that you have to figure out, these are where you have to really think. How long is the ball in the air? So you're trying to find t, right? T is represented by time. So you want to find t. All right, you have to ask yourself, well, how do I know when the ball is not in the air? Well, the ball is not in the air when the height is 0, right? When it hits the ground right here. It's not in the air there, and it's not in the air here. And so the height is 0, which is the y value. So I'm going to set 0 equal to this. And I'm going to solve. And so probably the easiest way to solve here is to factor out the t, -16t plus 150 sine 30. And so either t equals 0 or -16t plus 150 sine 30 equals 0. All right, t equals 0. Yeah, at time 0, my height was 0. There it is. Okay, so here, when I solve this, -16t equals -150 sine 30. Divide both sides by -16. And if you take the time to do that on your calculator, you're going to get that t equals 4.69 seconds. That's how long the ball is in the air. So look at part C. It says, oh, actually, let's not do C yet. Let's do part D next. Part D, determine the distance that the ball traveled. Okay, so the distance the ball traveled, you got to think about what that means. The distance the ball traveled is right here, and isn't that an x value? So you know that you have 4.69 seconds is how long it took. This will tell you the distance the ball travels. So you're going to multiply 150 cosine 30 times the 4.69, and you get 609.2 feet. That's how far this guy hit the ball. Blake can hit that ball. Part C says, when is the ball at its maximum height? So the ball is going up and it's going down. Isn't the maximum height right there? Probably the easiest way to do that is to recognize that for a parabola that starts at 0 and ends at 0, if this is 4.69 seconds to get here, then that would be half of it, wouldn't it? So you'd say this is for part D, you'd say 4.69 divided by 2, and that gives you 2.345 seconds. If you wanted to know exactly how high it was at that point, which is not, it's not asking that, but if this is 2.345 seconds, to find the height, couldn't you just put that in right here for the t's? And once you get the t's in there, then you can figure out exactly what the y is. If you just feel like doing that, I think you get like 87.9 feet or something like that. Okay, I want to talk a little bit about how you do this thing using the calculator functions. And so one thing that you could do is plug this in to y equals. Okay, so you're going to want to pause the video and do that. When you do that, you get something that if you're zoomed 6, you can't see the whole graph on there. And so I'm going to go to my window. Also, make sure you're in degrees. I'm going to go to my window and I'm going to change my y max. And I'm just going to put it at like 100. Because I know that other ball went up like 89 feet. So if I go 100, I can see exactly how tall it is. So on the graph, it's looking like this. And you should see that right here, it's hitting somewhere between the 4 and the 5. It's actually hitting at 4.69. So you could do, to find this point right here, second calc 0, and then go to the left and to the right, and you're going to find that that's 4.69. You could, right here, say second calc maximum, right? And then go to the left and to the right. And then what you'll find out is that this is 2.345. The x value is that. And the y value is that height, which is, I think it was, like I said, 89.9 or something like that. All right, so that's how you do it on the calculator. You want to spend some time doing that. We're going on to the next page that has a bunch of word problems. Okay, so we're going to go completely out of order, but we are going to start with question number 1. So you have, suppose a professional football player kicks a football with an initial velocity of 29 yards per second at 68 degrees. Here's the first problem. This is yards per second, and you got to have feet per second. So 29 times, hopefully you know there's 3 feet in a yard, is 87 feet per second. So you have this going like this at 68 degrees, and it's going 87 feet per second. So the first thing you're going to want to do is always write these two parametric equations. So x equals v cosine theta, 87 cosine 68 times t, and y equals negative 16t squared plus 87 sine 68t. And because it's a football player, he's kicking it off the ground, so the height is 0. So this would be like plus 0, which honestly you wouldn't even write. Okay, so he's kicking it off of the ground. So the question says, how far does the ball travel horizontally? And the kick returner catches the ball 5 seconds later. So how far does it go horizontally? So it's going to go up here, and somebody's catching it 5 seconds later. So the t is 5. If it asks for how far horizontally, doesn't that make you think that you need to use the x? So you put the 5 in right there. And so you have 87 cosine 68 times 5. And you should get, for part A, about 163 feet. Okay, pause it and use your calculator if you need to. I don't know what just happened here. Whatever. What is the vertical height? So you think vertical height, and automatically you think of the y. And so all you're going to do is put the 5 in here, and put the 5 in here. And when you multiply negative 16 times 5 squared plus 87 sine 68, all that times 5, you get 3.32 feet. When the guy caught it. Now think about it. That's what the height is. This guy catches it 5 seconds later. The kick returner, okay, it's not going to wait till it lands on the ground and then catch it, right? He's going to catch it. So you want to see if that seems legitimate, that he could catch it about 3.3 feet off the ground. I think that sounds legitimate. If it turned out to be 13 feet, boy, that guy can jump. But I don't think that's really going to happen. All right, so that is number 1. And we are going on to number 2. Nope, not to 2. We're going to 3. Okay, look at number 3. You have this golfer, Nancy Lopez. She hits a golf ball with a force to produce an initial velocity of 175 feet per second at an angle of 35. Okay, that next part, she estimates the distance to be 225 yards, ends up not mattering. So I'm just going to talk you through this. You should be able to write your two parametric equations, right? So 175 cosine 35t is the x, and the y is negative 16t squared plus 175 sine 35t plus 0, right? Because she's a golfer, she's hitting off the ground. Part B, when it says find the range of the ball, all right, that's a bad way to say it in a math class because range makes you think y and it makes you think about the vertical distance. But the range in golf is really going to mean how far, like x distance, can it go. So it's really wanting to find the x. Okay, so if you think about this, so you have x equals 175 cosine 35t. You really want this, but dang, I got an x and a t and I can't really figure that out. So sometimes you have to use the other equation. So you had this, right? And to find the range of the ball is going like this. If you want to find out how far this is, don't you know that the height here was 0 and the height here would be 0? Wouldn't that be the total range, the total distance of the ball? So if you want the height to be 0, you put a 0 in right here. And you're going to solve for t. And so when you solve for t, again, you're going to get something that looks like this, and you're going to be able to find, if you did a calculator, you would find the 0 here, and that would tell you what the t is. Or you factor this out, and frankly, if the h is 0, I think this is easier. So this equals 0, and then this part equals 0. Oops, equals 0 this side. And when you do this, you're going to find that the t is 6.27 seconds. Man, that's good if you can hit a golf ball and leave it up in the air for 6.3 seconds. I can't do that. Mine skids across the ground after about 0.1 seconds. But anyway, so this girl has it up in the air for this long. So now, isn't that what this is? So if you want to find the range of the ball, you can put in the 6.2 seconds right there, and then you end up finding out that it's 899 feet. Which, if you look at what she estimated, her estimate was pretty bad because she thought it was going to be 225 yards, which is like 600 some feet. Yeah, it wasn't that awesome. She was not going to hit the ball all the way unless there was a good wind behind her. All right, number 6 is the next one that we're going to talk about. And so you have on number 6, so you have some fireworks. They're going in an angle of 82 degrees with the horizontal. Okay, so 82 degrees with the horizontal. The technician firing the shells expects them to explode about 300 feet in the air 4.8 seconds later. All right, you want that thing to explode right here. You don't want like to be going and it explodes here and then your thing keeps on going up. You want to be at the very apex where it's exploding, and so you want that to be at 4.8 seconds. It says find the initial velocity of a shell fired from ground level. All right, so my two parametric equations would be v. I don't know the velocity yet. The initial velocity, cosine 82 times t, or negative 16t squared plus 82, plus v sine 82, right, times t, plus 0 because it was fired off the ground. If you had to find the initial velocity of a shell fired from ground level, okay, look, here's one thing that you know. At 4.8 seconds, it's going to be 300 feet up. At 4.8 seconds, it's going to be 300 feet up. Right? So now you should be able to solve for v. And if you do, you find out that it's 140.7 feet per second. That's it. Number 4 is a lot like it. So go ahead and work number 4, and you should get 158.3 feet per second and 230 feet as your A and B. It's going to be another video, so look for that.